Okay, so be prepared because I'm going to be asking you guys to come up and share something new. So what do you know about speed and velocity and acceleration and forces? Pick just one thing that you can share. Okay. So what makes objects faster?
Force.
Okay. So put force and put a little arrow to makes objects faster. So we need forces for objects to move. We don't have movement unless there's something that's making them move. Okay? Timothy, share one thing. Sure. Any one thing that you wish to share that's related to this. Whatever you wish. As long as it's related. We don't need to hear about something that's not related. So Kenneth tells us that if we have forces, we have objects that are moving faster. What's that word?
Both velocity caused by the force from the hammering on the fire line.
Okay. I had a hard time reading cause, so I'm going to rewrite that. Okay. So this really that he's given us is an example of a force. That we have an object that is now moving. That bullet is moving at a velocity because we have the hammering action of the firearm. Okay? Sydney, share one thing. Oh, Oh, I like it.
No.
I like it.
Oh, I'm doing
Speed equals distance over time. Tonight. You give up?
Yeah.
There's plenty of things that you can say.
Stole it.
Look, this week's can I
We'll see. And we'll see if it's left by the time we get to you.
This ain't fair.
I forgot how to spell acceleration.
I live in my
Hey, sounds good.
Acceleration. Now, Harmony, if I give you this, will you be able to write? Okay, just check it.
164.
You just like,
Oh, I like it. I like it. Okay, she says acceleration.
I got it.
I'm a genius.
I think.
oh my god.
I'm going.
I understand what you're saying. Okay, so just if you stay with the up. So she says acceleration is up. How about if I say?
Oh, okay. I'll just put it down.
I struggle sometimes in how to show it too. Like we're just trying to show the ideas that are currently running around in our head. Okay. So she says acceleration is positive. She also started to put up, and I'm perfectly okay with this up. I'm going to add that back in. She took it off, and deceleration is down. Now, when she's talking about that, and we have positive, negative, or up and down, I start thinking about lines. Like if we have it like this, or if we have it like this. Okay? This one, we're talking about a slope. Okay? Harmony? We have some good stuff. I like seeing what you guys have been learning. Now, is some of this stuff really new, or some of this is like, hey, I know that says I was like 5.
Wait,
There are certain things that, like, I swear we've known since we were 5. There's other things like slope that we probably just learned about in the last like year or 2. She's getting there. Acceleration. Final speed. Ooh.
Oh, okay, I see.
Subtract initial speed. Wow, you guys have been working ahead, I swear. I don't think we even did that one yet. Okay. That's fine. Final speed, subtract initial speed, divided by 9. Texas. I'm gonna make them wait for it.
If something sticks in my eye,
You gotta find a new idea.
don't
There's plenty of ideas.
take my idea.
Wait. Oh, that's a deep one.
Ah, okay. I liked it. That wasn't where I thought he was going at first. He says velocity equals speed and direction. That is important.
Don't. I am panicking right
Please, I'm not panicking.
I'm panicking because I have a good view associate. It's my idea.
I'm thinking about
It's okay. So balance as a force is simply a push or a pull. I like it.
Please,
Okay.
can I do one more?
David,
Okay. So,
you ready for it?
not really, but I think I got it. Okay. So.
Don't.
Ah, he just really wanted to write that word. He's like, speed
No, I
is
don't.
ignorant of direction. What does that mean?
I have no idea. I saw it and I went, oh, it's that. I went with it.
What does that mean? Speed is ignorant of direction.
It goes
I'm
anywhere.
nervous.
It doesn't, speed doesn't care about direction. Speed's just speed.
Yeah.
Okay? So I don't need to know a direction in order to know the speed of something. Christian,
Which one?
Okay.
Hodges.
Yay. Okay. Okay.
He's like, I don't
You
like
serious?
Tell you what, Christian, you get to do 2.
I don't want to do.
You have to do 2.
What?
A, B,
I don't know
R,
anything.
Yes, Harvey. Yes, speaking fast.
H.
I don't know anything.
Age, A-G-E. Average.
One page. Like lessons 1 to 4.
No, I was really just, yeah.
Oh.
Total distance. Well, think about it. If average what? Are we talking speed, velocity, acceleration? Put average speed. And you think about it, we talk about kilometers per hour, meters per second. That's distance over.
It's not.
What is
If I talk about
No.
meters per second,
Why not?
hour,
What?
distance divided by
That's not helping.
What is this? That is our, what are those?
Yo.
You missed. Okay, so Christian says that the average speed is our total distance or our total time.
Speed is a speed right now.
Okay. F.
Isn't acceleration basically equal to deceleration at the same time due to air force against like the object moving through and also
Not
gravity?
necessarily. It's not necessarily equal. If air resistance were the exact same force as us trying to move, we would be stuck like this.
Wait, what about if gravity comes into play? What about gravity that does the object?
Gravity does things too. We're not quite there yet. That's stuff that we are going to be looking at as we look at Newton's laws. But we'll talk about that in a second. So hold that thought. I'm going to do something up here that's not going to make any sense to you yet.
What if it does? Wow, what if it I don't.
It's okay if you don't know what it is. I'm just
sense.
putting it down because I'm trying to answer his question in a few minutes.
I kind of see. I kind of see where you're trying to go.
You see where we're going?
Yeah, I get it. I get it. A little bit.
It goes up and to the right, and it goes up and
You're talking about velocity. Right? Is that happening at the same time?
Yeah. Personally, like when I do these things, I try not to put too many words.
I
Like,
cannot spell it. Just to let you know, I
no,
cannot spell it.
he did perfectly fine. He said that's hard to do this down here. I know.
I cannot write.
He tells us that instantaneous speed is like at that second,
oh.
right? He says that speed of an object at a certain time. So, like if I were to measure like a runner as they are running through the track, if I were to measure the speed at different times, it probably would not be the same. Okay, it might be slower at the beginning, faster later on. What is one way that we use to measure instantaneous speed? No. Yeah, speedometer. Speedometer is usually, when we think about instantaneous speed, is when you look down at the speedometer in a car and you go, oh, I'm going 50 miles an hour. I'm only supposed to be going 45. Right? So we measure that using a speedometer. You only gave me one.
Exactly.
Two. Come on. Everyone think of the next one.
I know. I can see the board.
Do this one. Do this one.
Okay, hey, Christian. You do it.
He does it.
Come on.
I'm done.
No. Okay. That's not nice.
Come on.
I said I'm done.
Alright, let's see.
Now, do we start back here or do you want me to start back there again?
Yeah.
You really?
I know what I'm doing.
Yes.
Because they're going to take things before it gets to you again.
I just want to.
I guarantee there's
Wait, I think I know why David just wants it to go on that side just right.
Hey, I'm making it easier on you guys if you get two at once.
No, but I want to use more.
Come on this side.
Because by the time he gets to Kenneth, he's going to have to really think.
I'm
Really think of what to write.
Yeah.
So Timothy's just kind of like, they're going to take everything.
Well, I don't think they're gonna when I have
You don't think so? Velocity describes. Oh, hold on. Are you talking about this?
Huh?
Yo.
Oh, yeah, car stuff.
Okay, find a new thing.
Huh?
Something. I need something new.
Oh.
Whoa.
Yes, I got out of it.
Okay.
Something new.
I'm happy.
Something new.
I'm happy. I'm just
We're not doing for lesson 3. We're just doing lessons 1 and 2.
Oh.
1 and 2. I was just doing
Lessons 1 and 2.
Hello.
Christian, you want
Yeah,
one?
yeah.
No.
You already got it. You already got it. Don't be scared.
Hey, you 3 are going
I'll
down.
do it. I'll do it. I don't have to find one.
I'll do the next one.
I found one.
You found one?
I'll do the first one for the next chapter.
Here.
Or lesson, whatever.
No?
This is where I-
I'm done. That one's right here.
I got one.
Wait, can I do the
Okay, David, come on up.
Can I do the next lesson?
I need something new.
Come on.
I have some. I don't have nothing.
Start from him.
Oh, I have something if you will let me know.
I'm just looking at it.
Okay, I like it.
We don't have enough about velocity.
I agree.
More velocity, guys. More velocity.
It is direction aware?
Yes.
Okay. Now, the key thing that he has here, which I think he spelled wrong,
What is going wrong?
this here is a vector. Remember we used that term vector?
I spelled that correct. Oh.
We have a speed and a direction. Whenever we have a direction, directionality says, hey, I have a vector. Okay? I need the Christians, come on. You have nothing for me?
I have nothing.
Oh, dear Lord.
I'll do lessons too.
Okay.
Yeah.
I'll start the one.
You have 2 lessons full of information.
Yeah.
Oh wait.
Full of information.
Oh. Wait, don't I take it?
I have one.
Nope.
Oh, no, you do?
Oh, I thought we were only doing lesson one.
I got it. Every time I listen to you,
Okay, Mel says acceleration, change.
I already know what she gonna put.
Anyway,
Wow.
we're gonna have a difficult time reading that.
I don't know. I think some of y'all need to have a handwriting class with my grandma.
I knew.
Like, she's very strict. Like, if you write wrong, she will rip the paper up and let you do it again. I feel like y'all need that. 60-day thing?
Okay, so she says that acceleration is a change in speed, which is also a change in distance.
Wait. Miss Lee. I have a very small, let's be honest, I have the best notes in this class. I don't take notes.
Oh, wait.
I believe in myself.
I do take notes.
I believe in myself. That's what I do.
I did take notes, just a little bit. You don't need to write full sentences. Acceleration.
Are we recording this?
Yes, we should be.
We should be.
Yeah.
Sometimes I screw up. We are recording.
Yay. Acceleration is what sentences?
We already did.
What are you trying to write?
Okay, see, I have something new that's actually for
Yeah, I have something good too. I have acceleration. Object moving at a constant speed can be acceleration. That's what I'm
Called
calling
a change in velocity.
I go first, second.
So he says acceleration is a change in velocity.
Right. I have something about velocity.
Now,
I have a very important fact about acceleration.
I have something about velocity that hasn't been talked about.
I have something from
well, Texas is
acceleration.
next, so.
Yeah, then it's me, right? Huh? I think it's me. Yeah, it's me.
No, it's torture.
Wait.
Okay.
It's
Texas?
It's okay. It's Texas and me.
No.
Gosh.
It's
Deny. No, it's not.
Yes.
Absolutely.
I think it is.
Yeah.
No, it's not. Before me.
Can you tell me anything about units for acceleration?
Oh.
Or units in general?
Or
Go up again.
Or about graphics?
Come on, dude.
I should really consider.
Yeah, go burn me. Let me make sure you didn't. No, 1 minute, 1 minute. Okay. This isn't in the book though. So Pascal put
Yes.
I'm one.
What's that?
this is how
Yes,
oh, okay. I'm not spelling this backwards. Ooh. Oh. I'm kind of That's
Change in X over change in T. So what this is,
X is displacement.
yeah, this here is a delta,
Yeah, that's what
which says change in. So I'm gonna have like my x2 subtract x1. I'm trying to see the difference of change in the x position on the graph compared to the change in my time. So I would definitely agree with that. Okay, Denia, you ready? Yeah, sort of.
Wait. Okay. Yeah. Okay.
We're getting there, sort of, kind of, maybe.
Okay. Change direction.
I got running.
Ooh.
The mark.
Distance versus time shows speed. Ooh, I like it.
Oh.
I like it. I completely agree. If I have a graph like this, and I have this line, and this is distance, and this is time, now what specifically shows the speed?
The line. The slope.
The slope.
Rise over run.
What?
The slope.
Yes.
This is the slope. Rise over run.
Can I put that? Rise over run? No, you did.
Timothy.
It's gonna be a long one. I wrote it down with docs, but.
Hey, we don't need whole sentences, so.
Please, no whole sentences.
Please, it gets too crowded when we do whole sentences. This is.
Please don't do it.
I hope this equation is right. I really hope it is.
Ooh. Oh, so good.
Not cold water though.
It's not even cold.
I have no clue what that is.
Force equals object velocity acceleration, like plus this.
Sir, we do not need to know that.
Bro,
Let him do it. He just wants to write down.
I think you have too many ideas all in one thing that you're trying to combine into one sentence. Okay? So, we did learn that forces make things move, causes object velocity. And the acceleration, we don't know specifically what about the distance and gravity is causing less acceleration. So, what he's trying to write, and I'll write it for him, is he's trying to do multiple belts at the same time. He started saying, hey, forces make things move and have a velocity. I like that. But then he also says that if I have a velocity, but I add in velocity over a distance, and I have gravity acting on it too, that I'm going to end up with a deceleration. I'm going to slow down, but we don't know why yet. We don't have enough information to understand this. He's trying to make sense of this. Okay? forces acting on an object. And we know that we have gravity acting on an object. And we can have air resistance. If this was falling, this would be air resistance. Right? And if this were bigger than this somehow, it's going to force it out. So if this is bigger than this, it's going to allow it to come down.
So everything is involved around velocity?
Everything's involved around forces.
Oh, that makes sense.
Oh, because.
Okay? So we have pushes and pulls in all these different directions, and whichever pushes and pulls are bigger, essentially win.
Wait, wouldn't like deceleration and acceleration be like a force?
No, acceleration and deceleration are forces, but the forces can cause acceleration or deceleration.
Oh, super.
Hey, it's good questions. I like the questions. Okay? You ready, Sydney?
I am, actually.
Good. And Kenneth, you got one on deck?
This is fun.
Well, it's a whole lot better for today, especially as we're trying to get our brains back to working. To go, what's in there?
Knock on the door.
Honestly, that's a nice feeling for Monday after having a week off where we all just try to ignore the world and focus on our families and fun. And as long as you did your homework ahead of time.
Wait, what homework?
The stuff that was due
What
before
was
the
the
break.
stuff that was there?
Well,
You should have done stuff
wasn't it?
before.
I didn't pay attention to that because I was
on
sleeping.
Sabbath?
I was trying to.
Yeah.
Okay.
Yeah, everything was on Sabbath and was part of Google Classroom already. There was nothing new.
Well, you said it was
I was
a
just saying Star Wars and stuff.
Oh, I think I did it.
We had like 6 assignments to do
That was already there.
I think I did like 3.
Oh.
See?
Oh well.
I think I did.
Okay.
All that work for nothing.
Maybe next
Nice.
Kenneth, what's new? Can you come up with anything new? No one's come up with units for me. I haven't seen units. Like,
Units
I need units here.
N-I-T-X.
Or for speed.
Units.
What are my units for acceleration?
Acceleration, AT.
What are my units for distance?
Oh, I got it. Can I put it?
Come on, Kenneth.
Yeah, come on, Kenneth.
Here, I'll give you a hint. I'll give you a hint.
Distance.
Okay, we're gonna go with units here. If distance is meters and speed or velocity is meters per second, what's acceleration?
Where you go?
seconds. Seconds per minute.
Well, think about it. We have this acceleration is final speed subtract initial speed over time. If this is meters per second, and this is meters per second, and this is seconds, what are my units for acceleration? Meters per second divided by,
Second.
so I could say meters per second. Is there another way to write that?
Oh, yeah.
MSS.
There we go.
Harmony's like, oh, I have it.
Don't call on her.
Do we trust her to have it?
No.
Yes.
Yeah, I guess.
Thank you.
What is the other way of writing meters per second per second? Right, somewhere near acceleration.
Oh, you already did it.
Oh, we didn't. Yes, we did. There's another way to write this. What's another way to write this?
Yeah, I was doing that. I couldn't see. No, I was gonna write
Oh,
that.
you're going to write that?
Yeah, I couldn't see.
I'm gonna guess. I'm gonna take a stab at it.
I love it. I think you made my day just by saying that.
It's gonna be wrong.
Yeah.
It could be wrong, but hey,
Wait.
Yeah,
you
she's
never
gonna take a guess.
write if you never try.
Keep going.
Where is that?
I love how it's not red.
It's a millisecond?
Wait, that's meters per
Wrong.
second?
It is wrong.
Oh, that's what I thought of.
Okay.
Maybe you need the
Put a
line.
slash.
Oh, okay. Here is another way of looking at it.
That hurt.
It hurt, I'm sorry. It wasn't personal. So we have meters per second, right?
Yeah.
And when we divide by something, you know, if we want to get it, like we end up going like, this is like meters per second divided by times 1/second. You know what I'm talking about?
No. Yes.
Where you do the inverse
Yeah.
of multiply.
Oh, m/s.
Like if I'm doing like 1/4 and I divide that by 3, like how do I do the math?
Oh, that's a double. What do we call that?
That's when I go 1/4 times 1/3.
Yeah.
Okay? So we do the same sort of thing here. If we have meters per second divided by seconds, I can go meters per second times 1/2. And so it ends up being meters per second squared.
That makes
because we have, and so I can say meters per second squared.
That's crazy.
Now, would I necessarily think your brain to do all that?
No.
No. But I'm showing where this is coming from, but can I see the pattern?
Yeah.
Meters per second, meters per second squared.
Yeah.
That makes sense.
By the time you get high up in math, you'll actually be able to use the math to do this very easily just by doing a few simple changes in the equations. But for right now, it's important to know the units, okay? So distance, speed, velocity, acceleration, okay? This is, speed, velocity is a change in what? Let's say,
Direct.
let me put this up here, change in. Change in distance gives me speed or velocity. What am I changing in order to get acceleration?
Speed.
A change in speed. I could also say velocity. I'm okay with that too. Okay, so if I change in distance, I change in speed or velocity. I'm just realizing that probably a lot of the stuff that we're doing on the right is not on the screen. Okay. What are some equations for this? Okay, distance
I think I know it.
or position. I can say x2 minus x1,
This,
right?
isn't a distance equation root number x2 subtract x1 square plus y?
Huh?
Plus what?
Let me see what she's got.
I think
Okay, she's doing distance on a coordinate plane, which, yes, technically, that is correct, but that's not something that we're going to be doing anywhere close to this year. She says, hey, if I go from here to here, okay, then if I want to determine that distance, you guys have seen Pythagorean theorem before, right?
Yes.
That I can look at my change in, if we have Pythagorean theorem where we have x squared plus y squared is equal to c squared, c being the hypotenuse, that I can find what c is, what is the straight line distance, by saying c is the square root of x squared plus y squared. But we're not even there. I'm just saying, hey, ending position subtract initial position, you got distance. determine velocity?
Oh, I'm putting delta x over delta t.
Okay. Velocity is change in x over change in time, which is x2, x1. I could say t2, t1. Acceleration is going to be what?
Final velocity subtract starting velocity over elapsed time is t.
So that's really change in velocity over change in time, which is my v2 subtract v1, t2 subtract t1. So I can use these interchangeably. Like sometimes they'll give you like 2 different times. Like, oh, well, we started at, 2 minutes and then we go until 3 minutes. Or they could just say over a time of 1 minute. Like I can use these interchangeably. Whether I just said the change in t, or if I have to calculate what that change is. Or a change in velocity, or if I have to calculate it. But this is how we get these units. Okay, if I have graphs, if I have a distance time graph, and I have a slope, it's going to equal my velocity, or my speed. If I have a velocity time graph, what does the slope show me? If distance time shows velocity, what is velocity time going to show?
Acceleration.
Yeah. Slope will show the acceleration. Shocking. Do you guys know a lot of stuff already?
Yeah.
Yeah, you really, really do. Now, there's one thing that we haven't learned about, and I think we'll probably spend some time talking about it tomorrow. Let's see how much time do we have left.
Like 10 minutes.
10 minutes? Ooh, we might have enough time.
What are we going to talk about?
I want to talk about this graphing a little bit more.
Oh, I love stuff. Rise over.
Is the video going to be on Google Classroom?
Yes, I will be putting, actually it will end up being in the playlist. So check out the Google playlist. It'll be the last video once I upload it today. You guys knew a whole lot of stuff, and I'm very happy for that.
Oh, can I explain rise over run?
Well, I'm actually not really going to talk about rise over run that much. Although it is something that you talk about definitely more in algebra. I'm not sure about the pre-algebra.
Yeah, we had a whole
little bit.
No, actually,
A whole lot of it.
a lot of it was kind
So
of
rise over run.
Hate run.
This is change in y over the change in x. Okay, which is, okay, those drumsticks need to go away. Y2, Y1, X2, X1. Okay, so if I have a distance time graph, and I see a positive slope, what kind of motion do I have?
What do you mean motion?
Well, what's happening?
It's accelerating. Going up.
Nope, there's no acceleration here. Do you want to know what this looks like?
Sure.
A linear.
This is me walking.
Oh, so it's just straight?
Well, we're covering the same distance in the same amount of time. This is constant, a constant speed. Does that make sense? If I have this distance time, and my graph looks like that, what am I doing? Yeah. I have no change in distance. Standing still. What happens if I have this for distance time? You have a question?
If you were walking at a constant speed, say you were on a treadmill and the ground is moving faster than you, would you keep the constant speed still?
If you're on a treadmill and it's moving faster than you, eventually you would just fall.
Yeah, basically. Not like if the treadmill was like had a little bit more speed
But
than
one thing I guess he's trying to point out is the starting point, the frame of reference, is very important when we're looking at this sort of thing. So imagine that this here is being at the board, and this distance here is back of the room. Does that make sense? Like we're saying, hey, the board is D equals 0. Back of room is D equals some sort of positive number, right? So if I just walk to the back of the room like this, I look like that first graph. If I pause, I look like that second graph. You want to know what the third graph is?
Sure.
Down.
walking backwards.
Yeah, I'm just going back to the board. Constant speed, back to the board.
Is this gonna be on a test?
It could.
When is our test?
Not for a while.
Wait, but we leave like what last week? Well, so next week's gonna
Next
be our
week.
last week.
We have like
right?
3 weeks.
No, we have 3 weeks.
What?
3? So
3
next
weeks.
No,
Oh,
including this week.
But
We
I
leave
thought
on, like,
we
the
had,
18th.
I thought we had a 3 weeks break though.
We do.
No.
We do have a 3 weeks.
You have an extra week in January.
Oh, okay.
Wait, what?
So we get off at, we leave at like 19, at like the 18th, 19th.
Yes.
17th actually.
Next
Oh, so that's-
week,
We leave on a
18th,
Thursday, no?
I'm not
Oh.
sure.
That's the end of the term, isn't it?
Yeah. So at any rate, we have more
Yeah,
time.
we have time.
So I time
You have a question?
I'm ready to go home.
No?
Sir, no, I got
Okay, does this stuff make sense, guys?
I guess. Yes.
Kind of.
Kind of?
Yeah.
Sort of?
About the last graph.
Okay.
You said it's walking backwards.
No, well, it's walking back
Almost an ice cream.
to the board. It's returning to whatever the reference point is. This is my starting point.
But that wouldn't be changing the speed.
It isn't.
How
There's
would
no
it be
change in
changing
speed.
If it's what is it?
All we're doing is here I moved away from the board, same speed. Here I return back to the board, same speed.
Does this have to do with proportional?
So it ain't no constant speed.
We're, we're actually not going to be talking about that at this time. I just don't worry where you're heading on that. I just don't know if I want to go that direction for the moment. So what's happening here? It's similar here. Something is constant, once again. So distance time,
Velocity.
constant speed.
Oh.
Velocity time is going to be constant. We talked about it earlier,
Distance,
which is,
velocity.
we already have that here. If we have a change in velocity over a change in time, what do we get? Acceleration. So in this case, I'm constantly accelerating. That's when you just put your foot on the gas pedal, and we get this constant increase, increase, increase. If we're falling due to gravity, okay, we'd have a constant acceleration. We'd constantly be speeding up because the force is acting on us. How about this? Look for the pattern.
Oh, never mind.
It follows the same pattern as the distance time. What's happening now? Standing still was also known as like the same position. we're always at the same distance. So what's the same here? This is constant something. The constant we're saying. Velocity. This is if someone were traveling down the road going 40 miles an hour, 40 miles an hour, 40 miles an hour, 40 miles an hour.
That's slow. I'm gonna say about at least 80.
Same.
I'll be going 110.
Oh, 40.
80 will be going
What neighborhood
80,
are you
sometimes
traveling
90.
through?
I'll be going 110.
Definitely.
Mine will be going 80,
On my
sometimes
phone.
Let me run the GPS.
On my phone.
How about you?
I go 110 miles an hour.
Okay. So what's this?
walking back,
It's going backwards. It's walking.
walking back.
We're not walking back.
Oh,
And good. Perfect timing by the
Hey
way.
guys, I didn't dismiss you. Have a seat.
he was about to dip.
You have to answer this one last question for me.
Walking backwards.
We're not walking backwards. What's
Walking
changing?
forward to the
What
right.
do you mean? Velocity.
This is high velocity. This is low velocity.
You're going faster.
Josie.
Increasing velocity.
Not moving.
Sit down.
We're not gonna
Okay, I'm sitting down.
Which means
Sit down in a chair.
we're decreasing the velocity. What do we call that?
Deceleration.
Deceleration. Okay, you may go.
One was about to dip. That's up halfway.